right, pre-algebra, this is lesson 28. It has 4 sections, 2 top half, 2 on the bottom half. The first section that we're reviewing is changing improper fractions to mixed numbers. I like this visual because it, makes sure you know what is going on in your head when you think of mixed and improper fractions. So 1, 2, 3, 1, 2, 3, these are split into 3 equal parts. So I would like to say this is 1/3, this is 1/3, this is 1/3, and I would like you to go ahead and write that down on your picture. 1/3 and 1/3. And this sentence tells us the fraction 10/3 tells us that we are considering 10 of these parts, each of which is 1/3 of a whole. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 1/3, or 10 thirds. Okay? A third, a third, a third, a third, 10 of them. Alright, so that's what's going on when you see an improper fraction. Another way to look at this is, well, this is 1 whole, this is 1 whole, this is 1 whole, and this is 1/3. Put that all together, you've got 1, 2, 3, and a third. So this is the 2 different ways to write the same thing. This picture can be written 10 pieces of thirds, 10 of them, 10 pieces of pie that are a third each, or 3 whole and 1 little third left over. 3 and 1/3, like kind of added together, joined, mixed with the fraction. A whole number with a fraction is why it's called mixed. This is a whole number mixed with a not whole number. Mixed. All right. Improper means big on top. Yeah. Anyway, so how do we change anytime we want to improper to mixed form? Well, you cut this into 3 equal parts, right? 3 goes into 10. 3 times 9. 1 left over. The leftover is your extra piece. And they're thirds. That's what size they are. Thirds stays thirds. So you divide. All right? We're going to cut this one into 5 equal parts. This is into 8ths, and this is into 4ths. So we just use the number, the bottom number, because it tells you what size piece it is. All right, so 5 into 14 goes 2 for 10. Then you subtract, and your 4 is your numerator. Your leftovers, your remainders is on top. Your numerators, how many pieces are left out of fifths? 4 fifths. 8 into 21, bottom into the top. That's another way to say it. Goes not 3, but 2 for 16. Subtract. 11 minus 6 is 5. 2 and 5 eighths. Remainder, yes, that's your remainder pieces. You don't have enough to make another whole, so the remainder goes on top. You have 5 pieces left, and they're eighths. Cool, you can do the last one, and we'll check it in class. And then next, well, what if you have a mix and you want to go back to improper? Well, instead of dividing and then subtracting, we're going to have to multiply then add. The opposite operation. Go forwards, then backwards. Let's work backwards through the problem. I like to say big times bottom plus the top. So we divided to get this, and then we subtracted to get this. So we're going to add this back, undoing the problem, and instead of dividing, we're going to have to multiply. So I like to say big times bottom plus the top. So big times bottom, 3 times 3. You have 3 big pieces of pie, right? And we're going to cut it into thirds. And that gives us 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 times 3 is 9, plus the 1 on top, which gives us 10 thirds. Doesn't that look familiar? Yeah, that's why I picked it. So that we try it over here. If it works for this, it's going to work for this. Big number, which is the whole number, times the bottom, which is the denominator. Big times bottom, 55, plus the tops, 56, 57, 58. Big times bottom plus the top. Try it. We'll check it in class. All right. And then there's one more section to this lesson 28. And they want you to be able to change mixed to a decimal and a decimal back to a mixed, which I think you can handle. Let's see. Mixed to a decimal. Well, this is 3 and 1/8, or you say 3 and 1/8. So how do you change a mix to a fraction to a decimal anyways in the first place? Pretend it's not mixed. Pretend it's just 1/8. How do we change that to a decimal? Decimal, divide, yes. You would divide the bottom 8 into the top, and it won't fit. So if you're looking for a decimal, you add a decimal 0. Oh, there's my decimal. 8 goes into 10 one whole time. 1 times 8 is 8. Let's do our regular division like normal. Add another 0. Keep going. Add another 0. Keep going because it stops right here. It's 0.125. 1/8 is 0.125. But this is 3 and 1/8. So this is 3 and 1.125. So it is 3 and 125. Pretty easy? I mean, you deal with your fraction like we've been dealing with our fraction. Divide the bottom into the top. And then the whole number is just in front of the decimal. That and that. So let's say 32 and 1/5. Well, don't we know that 1/5 is 0.2? Yes, it is. 1/5 is the same thing as 0.2. It is. 2/10. 1/5 is 2/10. So this is 32 and 1/5. So this is 32 and 2/10. So that's just the fraction version, mixed, and this is the decimal version. So you basically separate them for a second, figure out the decimal version of this, and then put them back together. Pretty cool? Easy peasy? You can handle it. And then one more. If we're ever changing a decimal back to its fraction world, we say it, write it, simplify it. This is in your previous notes. You already know this. But let me show you it works with mixed numbers as well. Like here it is. 3, say it. 3.1, no, say it formally. Say it properly. 3 and 1/10. Write it. 3 and 1/10. Simplify it. Oh, it's already simplified. Yeah? So how would you say that? 7.5. No! Formally, how do you say it properly? 7 and 5/10. So you say it, you write it 7 and 5/10, and then you simplify it. Doesn't a 5 go into both of those for 7 and? I'll let you finish that and I'll check it in class. Hey, if you'll do me a favor and try out these rules, A through F, page 95, go ahead and open your book, work the problems right here, somewhere next to these notes. I want to know that you did them before you come to class, and you're doing great, pre-algebra.